Hey everyone, welcome to my YouTube channel, Zenith GATE Mechanical. So in the today's session, I will talk about what are the questions which were asked in the GATE 2025 Mechanical from the subject Strength of Material and the Engineering Mechanics. Before come to the question, I just want to tell you what is the weightage of the question from these two subjects. So if I will talk about in the engineering mechanics, so two questions were asked. Both question carry 1 marks. That means the total marks will be 2. And in strength of material, total 4 questions was asked, out of which 1 question carry 1 marks and 3 questions carry 2 marks. That means the total weightage will be 7 marks from the strength of material and 2 marks from the engineering mechanics. Okay, so let's start the question series. So this is the first question from the strength of material. What is the question? A metallic square plate is subjected to a uniform hydrostatic pressure. Choose correct Mohr circle representing the state of stress at any point in the plate from the option given below. Okay, so the 4 options are given. You have to identify which one is the correct representation of Mohr circle for the hydrostatic pressure condition. Okay. So first of all, you understood what do you mean by hydrostatic condition. So the question given, there is a plate which is subjected to a hydrostatic pressure. Hydrostatic pressure means from all the sides, the pressure P is acting, and this will be nothing but in compression. That is nothing but in compression. Okay. So from this diagram, if I want to write down what is the sigma x value, minus P. Sigma y is also minus P. Or you can also write sigma 1 is nothing but minus P only. And sigma 2 is nothing but minus P. Why? Because there is no shear component of stress is acting on this particular square plate. Okay. Now, there is no shear stress means the tau value will be 0. Tau value will be 0. So what is the radius of Mohr circle? The radius of Mohr circle you can easily calculate by using this particular relation, which is nothing but sigma x minus sigma y by 2 whole square plus tau square. Okay. So tau value is 0 and sigma x value is nothing but minus P, and this minus of minus P will become plus P divided by 2 square plus 0 square. So minus P plus P is nothing but it is a 0 only. That means the radius of Mohr circle in this particular question is 0. Okay. So to represent the Mohr circle, so the x-axis is basically is nothing but the normal stress and the y-axis is nothing but the shear stress. So sigma 1 value is minus P and sigma 2 is also minus P. So can I write? Let us suppose this is the minus P. That means both points are acting at the same position. That means sigma 1 and sigma 2 both are equal, and which is nothing but minus P. And you know that the radius of Mohr circle is 0. That means the radius of Mohr circle is 0 means the Mohr circle is reduced to a point. And this is very important concept. So I'm writing in the form of note point under the hydrostatic condition, under hydrostatic, under the hydrostatic condition, the Mohr circle is reduced to a point. Okay. So for this question, what is the correct answer? So the correct answer will be the option B. B will be the correct for this question. So choice B is the correct. Okay. So next question, this question from the engineering mechanics. So truss is given. For the given truss, among the option given, which member is zero force member? That means you have to identify in a particular truss problem which member is carrying the zero force. Okay, so the four options are given. Option A is BD, option B is AD, option C is BC, and option D is BA. Okay. Now, if you observe, if you consider the joint B, so the joint B is nothing but at the joint B, the three members are there at this particular joint. If you will draw a free body diagram of this point, so what are the forces acting? The force, let us suppose this is force AB, and this force I am representing as a force BC, and this force is nothing but the force BD, which is perpendicular to other two forces, which is already given, force BD. Now you can see here, this is perpendicular. Okay. Now let us suppose this is the y-axis and this is the x-axis. This is the x-axis. Now, if you write down the summation of force in x direction 0 and the summation of force in y direction 0, so from the force in x direction 0 means only one force, which is nothing but the internal force on this BD member is acting. So the force in BD is equal to 0. If you see this point B, summation of force in the y direction 0 means the force BC is equal to force AB. Force BC is equal to force AB. That means at this point, this force is balanced by this force, and then there is no force which is balancing this force BD. That means the force in the BD member will be 0. Force in the BD member will be 0. So the correct answer for this question is, you have to identify which option will be correct for zero force member. So the correct answer will be the option A. So now I'm writing one more important note point from this particular question. So whenever you see if the three members are meeting at a point, are meeting at a joint out of which two are collinear, then the force in the third member will be 0. Third member will be 0. For this particular question, the option A is the correct. So choice A is the correct answer. Choice A is the correct. Okay. So whenever you see three members are meeting at a joint, out of which two are collinear, then the force in the third member will be 0. But please make a note of this. There is no force which is acting at this joint in this direction. Otherwise, let us suppose if there is a force 10 kilonewton, so this 10 kilonewton will be balancing this force. So in that case, the force on the BD member will not be 0. But in this case, there is no force which is acting at a joint in the direction of BD. That means the force in the BD member will be 0. Okay, so now move to the next question. So what is the question? A rigid circular disc of radius r in meter is rolling without slipping. Okay, so always remember, whenever they have mentioned the rolling without slipping means it is a pure rolling case. On a flat surface as shown in figure below, the angular velocity of disc is given as omega. The velocity at point O and the velocity at point A you have to identify. For that, they have given you the four option A, B, and C, D. Okay, so let's try to understood. First of all, what is the pure rolling, or what is the rolling? So first of all, the rolling is nothing but it is the combination of translation plus rotation. Translation and the rotation motion. Okay, translation and the rotational motion. So for example, there is a rolling. Rolling means, let us suppose I'm considering there is a pure translation motion, and there is a pure rotational motion, because the rolling is nothing but it is a combination of translation and the rotation motion. Let us suppose if a body is doing pure translation, that means each and every particle will be in the translation only. Yes or no? Each and every particle will be in the translation only. Now, that means it is moving with the same velocity, let us suppose v. In the case of rotation, in the rotation means this body is rotating about this point O with certain angular velocity omega, and this body having a radius r. So in a pure rotation means, so at this point, if you want to write down their velocity is nothing but is equal to r into omega. Okay. So tangential to the each and every point will give you the velocity. So this is also the velocity at this point, v is equal to r omega. So at this point also you can calculate, this point also you can calculate, which is nothing but v is equal to r omega. That means each and every point, if you want to calculate the velocity, just draw a tangent. The velocity will be along the tangential to that particular point. Okay. Now, if you join these 2 points, so the velocity at this point, which is nothing but, let us suppose I am assuming this is a point and this will be the b point, a point and this is b point. So the velocity at b point will be in this direction and velocity at a point will be in this direction from the rotation. But in case of translation, the velocity at a point in this direction, which is also having the same magnitude, because I have already told you it is a rolling without slipping means, or rolling without slipping means, rolling without slipping is nothing but it is a pure rolling. Pure rolling case, you can write v is equal to r omega. V is equal to r omega. V is equal to r omega. Okay. So if I want to draw a combined picture of these two, translation and rotation, so what you will get? So let us suppose, again, the same body I am taking. So at this point, the v will be coming from the translation and the same v is coming from the rotation. So it will add up, then you will get that 2v. Now at the point A, the velocity at point A in the forward from translation and rotation in the backward. So I can say the velocity at A point will be 0. What about the velocity at O point? The velocity at O point only in translation. Rotation means because r value is 0 at this O point. Okay, so this is also a velocity. Okay, so in this question, you have to identify what is the velocity at A point as well as the O point. And it is given, this direction is I cap and this is j cap. So this is I cap, this is j cap. So if I want to write down the velocity at O point is v, which is nothing but in pure rolling r omega I cap. Similarly, the velocity at A point will be 0 I cap. 0 I cap. Why? Because in translation, the velocity vector in the forward, and in rotation, it is acting in the backward, both having the same magnitude, it will cancel out. That means at the point of contact in pure rolling, the velocity will be 0. So out of these 4 options, which one will be the correct? The option C is the correct answer. The choice C is the correct answer. Okay.